For this problem, we have to figure out how many of the snowman had hats. We know that Holly, Katsuki, and Romy each drew 2 snowmen. We also know that Holly and Katsuki placed a hat on each of their snowmen, and Romy did not. So this means Holly placed a hat on her 2 snowmen, and Katsuki placed a hat on her 2 snowmen. So solving this equation, we have 4. So the answer to this problem is 4 snowmen. For this problem, we have to figure out how many balloons were picked. We know that there were 5 red balloons and 7 blue balloons to give away. We also know that after some kids got their balloons, there were only 3 blue balloons left. To solve this problem, we can do 5 plus 7 minus 3, and we get 9. So the answer to this problem is 9 balloons. For this problem, we have to figure out how many wheels there are in total. We know that her mom and dad each have 2 bicycles. We also know that Joanna and her little brother each have a tricycle. Since each bicycle has 2 wheels and her mom and dad each have 2 bicycles, that means her mom and dad each have 4 wheels. Since each tricycle has 3 wheels, and Joanna and her little brother each have 1 tricycle, Joanna and her little brother each have 3 wheels. So the total number of wheels would be 4 plus 4 plus 3 plus 3, which is equal to 14. So the answer to this problem is 14 wheels. For this problem, we have to figure out how many more paper flowers she needs to cut. We know that she cut 5 paper flowers. We also know that she wanted to decorate 2 walls in her room, and she wants to have 8 paper flowers on each wall. To solve this problem, we have to figure out how many paper flowers she needs, and then subtract the number of paper flowers she already cut out. To figure out the number of flowers she needs, we can do 8 plus 8, and we get 16. Now let's subtract out the number of flowers she cut out, and that would be 5 flowers. So we would do 16 minus 5, and we get 11. So the answer to this problem is 11 flowers. For this problem, we have to figure out how many coins he gave to Naomi. We know that he made 18 cranes out of blue origami paper and 13 cranes out of green origami paper. We also know that he gave some of the cranes to Naomi, and he had 15 cranes left. To solve this problem, we have to figure out how many cranes he made in total, and subtract the number of cranes he had left, since he could only give the cranes to Naomi, or he could keep the cranes. And since we have to figure out how many cranes he gave to Naomi, we have to subtract the number of cranes he kept. So the equation would be 18 plus 13 minus 15. And this would result in 16. So the answer to this problem is 16 cranes. For this problem, we have to figure out how many people are sitting down and enjoying their meal. We know that a local restaurant has 12 tables set up and each table can seat 4 people. We also know that at noon, all of the seats except for 7 are taken. We can solve this problem by finding the total number of seats and then subtracting the number of empty seats. We can figure out the total number of seats by doing 12 times 4, since there are 12 tables and each table can seat 4 people. So 12 times 4 is equal to 48. Now let's subtract the number of empty seats. We know that all of the seats except for 7 are taken, so that means there are 7 empty seats. So we can do 48 minus 7, and we get 41. So the answer to this problem is 41 people. For this problem, we have to figure out how old Ryan is. We know that Ryan is 4 years older than his sisters who are twins, Rihanna and Anna. We also know that if we add up all of their ages together, the sum is equal to 19. Let's represent the age of Ryan's sisters, who are twins, was 1 unit each. So that means Rihanna's age is equal to 1 unit. This also means Anna's age is also equal to 1 unit. From the problem, we know that Ryan is 4 years older than his sisters, so that means Ryan's age is equal to 1 unit plus 4. From the problem, we also know that the sum of all of their ages is equal to 19, so that means Rihanna's age plus Anna's age plus Ryan's age is equal to 19. So this means 1 unit plus 1 unit plus 1 unit plus 4 is equal to 19. We can simplify this and we get 3 units plus 4 is equal to 19. Subtracting 4 from both sides, we get that 3 units is equal to 15. Dividing both sides by 3, we get that 1 unit is equal to 5. Now let's figure out how old Ryan is. We know that Ryan's age is equal to 1 unit plus 4, so this means it is equal to 5 plus 4, which is equal to 9. So the answer to this problem is 9 years old. For this problem, we have to figure out how many bicycles were in the bicycle rack using the clues above. One of the clues above is that Amico parked her bicycle in the middle of the second row. Let's use a circle to represent Amico's bicycle. Another clue above is that there are 4 bicycles to the left of Amico's, so let's draw 4 bicycles. Since Amico's bicycle is located in the middle, that means there are another 4 bicycles to the right of Amico. So let's draw 4 bicycles. From the problem, we know that there are 2 identical rows, so that means the first row is identical to the second row. So that means the first row also has 9 bicycles. As you can see, we have 18 bicycles here, so the answer to this problem is 18 bicycles. For this problem, we have to figure out how many of her art got special recognition. We know that she entered 25 of her art into a competition. We also know that the number of her art that received special recognition are 7 more than the ones that did not receive any recognition. Let's represent her art that received no recognition was 1 unit. From the problem, we know that the number of her art that received special recognition are 7 more than the ones that did not receive any recognition. So that means her art that got recognition is equal to 1 unit plus 7. From the problem, we also know that she entered 25 of her art into a competition. So that means her art that got no recognition plus the art that got recognition is equal to 25. So that means 1 unit plus 1 unit plus 7 is equal to 25. Simplifying this equation, we have 2 units plus 7 is equal to 25. Subtracting 7 from both sides, we have that 2 units is equal to 18. Dividing both sides by 2, we have that 1 unit is equal to 9. Now we can solve this problem. We have to figure out how many of our got special recognition. So that means we have to solve 1 unit plus 7. And we know that each unit is equal to 9. So that means this is equal to 9 plus 7, which is equal to 16. So the answer to this problem is equal to 16. For this problem, we have to figure out how much money she spent altogether. We know that she had $36 and she spent 1/6 of her money on the book. We also know that she spent 2/5 of her remaining money on the calculator. To solve this problem, we can first figure out how much she spent on the book and then add how much she spent on the calculator. We know that she spent 1/6 of her money on the book, so that means she spent 1/6 of 36, which is equal to $6. Now let's figure out how much she spent on the calculator. We know that she spent 2/5 of the remaining money on the calculator, so we have to figure out the remaining money. And we can figure out the remaining money by taking 36 and then subtracting the cost of the book, which is 6. We get 30. So she has $30 remaining, and we know that she spent 2/5 of that remaining money on the calculator. So that means she spent 2/5 of $30, which is equal to $12. Now we can add up the cost of the book plus the cost of the calculator, and we get how much she spent altogether. So that would be 6 plus 12, which is equal to 18. So the answer to this problem is $18. For this problem, we have to figure out how many cookies there were in each packet. We know that she baked 9 trays of cookies and there were 20 cookies in each tray. We also know that she gave away 1/5 of the cookies to her friends and 4/9 of the remainder to her sister. Finally, she packed the rest of the cookies into 4 equal packets. Let's start by figuring out the number of cookies she had in the beginning. We know that she had 9 trays of cookies and there were 20 cookies in each tray. So that means she had 9 times 20 cookies in the beginning. And this is equal to 180. She then gave away 1/5 of the cookies to her friends, so that means she has 4/5 of the cookies remaining. So she has 4/5 of 180, which is equal to 144. Next, she gave away 4/9 of the remainder to her sister, so that means she has 5/9 of the remainder. So she has 5/9 of 144, which is equal to 80. Finally, she packed the rest of the cookies into 4 equal packets. So that means the number of cookies in each packet is equal to 80 divided by 4, which is equal to 20. So the answer to this problem is 20 cookies. For this problem, we have to figure out the total weight of two dogs. We know that Mikhail's dog is 18 pounds heavier than Jenna's dog. We also know that the weight of Jenna's dog is 3/5 the weight of Mikhail's dog. Let's use a model to help us solve this problem. We can represent the weight of Mikhail's dog using 5 units. And we can represent the weight of Jenna's dog using 3 units, since Jenna's dog is 3/5 the weight of Mikhail's dog. From the problem, we also know that Mikhail's dog is 18 pounds heavier than Jenna's dog, so that means these 2 units represent 18 pounds. And since there are 2 units, that means each of these units represent 9 pounds. Now let's figure out the total weight of the 2 dogs. As you can see here, there is a total of 8 units, so the weight of the 2 dogs is equal to 8 times 9, which is equal to 72. So the answer to this problem is 72 pounds. For this problem, we have to figure out how many strawberries were in the basket. We know that 3 friends shared a basket of strawberries. We also know that Sandalia got 2/7 of the strawberries, Jack got 33 more strawberries than Sandalia, and Francis got 78 strawberries. Let's have x equal the total number of strawberries. From this problem, we know that 3 friends shared a basket of strawberries, so this means Sandalia's strawberries plus Jack's strawberries plus Francis' strawberries is equal to x. So this means 2/7 of x, which is Sandalia's strawberries, plus 2/7 of x, plus 33, which is Jack's strawberries, plus 78, which is Francis' strawberries, is equal to x. Simplifying this equation, we have 4/7 of x plus 111 is equal to x. Subtracting 4/7 of x from both sides, we have that 111 is equal to 3/7 of x. Dividing both sides by 3/7, we have that 259 is equal to x. So the answer to this problem is 259 strawberries. For this problem, we have to figure out how far it is from Redland to Blueville. Let's draw a picture to help us solve this problem. Let's have Redland on this side and Blueville on this side. From the problem, we know that we pass a sign that says Blueville in 5.6 miles, so that means the distance between the first sign and Blueville is 5.6 miles. We also know that after riding for 1.9 miles, we see another sign that says Redland in 4.6 miles, so that means riding for another 1.9 miles, we see a second sign, and the distance between the second sign and Redland is equal to 4.6 miles. Using this information, we can figure out the distance from Redland to Blueville. We can do this by first figuring out the distance from Redland to the second sign, and then figuring out the distance from the second sign to Blueville. We already know the distance from Redland to the second sign, which is 4.6 miles, so we just have to figure out the distance from the second sign to Blueville. We can figure out this distance by taking 5.6 and then subtracting 1.9, so we have 5.6 minus 1.9, and we get 3.7. So that means the distance from the second sign to Blueville is 3.7 miles. Now we can add up these two distances, and we get our total distance. So that would be 4.6 plus 3.7, and we get 8.3. So the answer to this problem is 8.3 miles. For this problem, we have to figure out the length of the longer piece. We know that she cut a wire into 2 pieces and the length of the shorter piece is 2/11 of the total length of the wire. We also know that 3 times the length of the shorter piece is equal to 147 centimeters. Let's have x equal to 1/11 of the total length. Since the length of the shorter piece is equal to 2/11 the total length of the wire, we know that the length of the shorter piece is equal to 2x. We also know that 3 times the length of the shorter piece is equal to 147 centimeters. So that means 3 times 2x is equal to 147. Simplifying this equation, we have 6x is equal to 147. Dividing both sides by 6, we have that x is equal to 24.5. Now let's figure out the length of the longer piece. We can figure out the length of the longer piece by subtracting the length of the shorter piece from the total length. The total length is 11x, and the length of the shorter piece is 2x, so we get 9x. So that means the length of the longer piece is equal to 9x. We know that x is equal to 24.5, so we can substitute 24.5 for x. So we have 9 times 24.5, and we get 220.5. So the answer to this problem is 220.5 centimeters. For this problem, we have to figure out how many blue magic pens there were at first. We know that the store had a total of 350 red and blue magic pens. We also know that after 1/3 of the red magic pens and 1/2 of the blue magic pens were sold, there were an equal number of red and blue magic pens. Let's have R represent the number of red magic pens. And let's have B represent the number of blue magic pens. We know that the store had a total of 350 red and blue magic pens, so that means R plus B is equal to 350. We also know that after 1/3 of the red magic pens and 1/2 of the blue magic pens were sold, there were an equal number of red and blue magic pens. After 1/3 of the red magic pens were sold, there were 2/3 of the red magic pens remaining. So that means 2/3 of the red pens is equal to 1/2 of the blue pens. Since after 1/2 of the blue pens were sold, 1/2 of the blue pens remain. We can solve this problem by solving this equation, and we can solve this equation by removing one of the variables. In this case, let's remove b. So we can do that by multiplying this equation by 2, so we have 4/3 of the red pens is equal to the blue pens. Now we can replace the b in this equation with 4/3 r. So our new equation would be r plus 4/3 r is equal to 350. Simplifying this equation, we have 7/3 r is equal to 350. Dividing both sides by 7/3, we have that r is equal to 150. We know that r plus b is equal to 350, so that means b must be equal to 200. So the answer to this problem is 200 blue magic pens. For this problem, we have to figure out the length of the longest side. We know that the lengths of the sides of a quadrilateral are consecutive multiples of 6. We also know that the perimeter of a quadrilateral is 156 inches. Let's have x represent the length of the shortest side. Now let's list out the lengths of all of the sides. Let's have the shortest side on this end, and the longest side on this end. We know that the length of the shortest side is equal to x, since x represents the length of the shortest side. From the problem, we know that the length of the sides are consecutive multiples of 6, and since x is equal to the shortest side, that means the second shortest side must be 6 longer than the shortest side. So the second shortest side is equal to x plus 6. And using this logic, we know that the second longest side is equal to x plus 12, and the longest side is equal to x plus 18. From the problem, we know that the perimeter of the quadrilateral is 156 inches, so that means the sum of all of these sides is equal to 156 inches. So we have x plus 6 plus x plus 12 plus x plus 18 is equal to 156. Simplifying this equation, we have 4x plus 36 is equal to 156. Subtracting 36 from both sides, we have that 4x is equal to 120. Dividing both sides by 4, we have that x is equal to 30. So that means the length of the shortest side is equal to 30 inches. We know that the length of the longest side is equal to x plus 18, so that means the length of the longest side is equal to 30 plus 18, which is equal to 48. So the answer to this problem is 48 inches. For this problem, we have to figure out how much they spent altogether. We know that they have a total of $280 to spend. We also know that after Miss Dorsey spent 2/5 of her money, and Miss Quazza spent 2/3 of her money, they had an equal amount of money left. Let's have x represent the amount of money Miss Dorsey has. And let's have y represent the amount of money Miss Quazza has. We know that they have a total of $280 to spend, so that means x plus y is equal to $280. We also know that after Miss Dorsey spent 2/5 of her money and Miss Colassa spent 2/3 of her money, they had an equal amount of money left. So that means the remaining amount of money is equal. Miss Dorsey spent 2/5 of her money, so that means she has 3/5 of her money remaining. So that means 3/5 of x is equal to 1/3 of y. Since Miss Colassa spent 2/3 of her money, we can solve this problem by solving this equation, and we can solve this equation by removing one of the variables. In this case, let's remove y. We can remove y by multiplying this equation by 3, so we have 9/5 x is equal to y. Now we can replace the y in this equation with 9/5 x, so our new equation will be x plus 9/5 x is equal to 280. Simplifying this equation, we have 14/5 x is equal to 280. Dividing both sides by 14/5, we have that x is equal to 100. We know that x plus y is equal to 280, so that means y must be equal to 180. From the problem, we know that Miss Dorsey spent 2/5 of our money, so that means Miss Dorsey spent 2/5 of 100. We also know that Miss Colassa spent 2/3 of her money, so that means she spent 2/3 of 180. Simplifying this equation, we have 40 plus 120, which is equal to 160. So the answer to this problem is $160.